All right, good afternoon, ladies and gentlemen. This is going to be your new lesson for the afternoon. Very important is that you have a piece of paper, a lined piece of paper that you keep in a safe place, or you have your journals. And so the very first thing that you should do is write this title in your table of contents at the front of your journal, and then find your next blank page on the right side. That's where we're going to take our notes, and title it 6.1 Linear, Quadratic, and Exponential. And then you're going to divide your paper into linear, quadratic, and exponential. I just drew little squiggly lines and I just put them down my paper like that. Okay, now we're going to take some quick notes about the differences between linear, quadratic, and exponential functions. Okay, so the first thing, draw a line down there. The first thing that we want to be able to do is differentiate between their graphs. I'm going to use a different pen. The graph of a linear equation forms a line. And that makes sense. Linear line. And there are 4 different ways that we can represent our linear equations. Positive sloping line, negative sloping line, undefined line, and zero slope line. Our slope man, our slope dude. Our quadratic equation forms a parabola. And there are 2 different ways that we can represent our parabola. This one opens down like a frown, and this parabola opens up like a U. An exponential equation forms what's called a curve. The curve either goes up or the curve either goes down. Keep going. Let's differentiate based off of seeing their equations. Oh, I smeared that really terribly. So linear equations would be y equals mx plus b. A singular x without an exponent or a squared is going to give you a linear equation. Other types, this is slope-intercept. Then we have ax plus by equals c. That's your standard equation. And then we also have y minus y1 equals m times x minus x1. That's your point slope equation. Again, there's just a singular x. No exponent, no squared, just a singular x. The quadratic equation is going to be something like y equals ax squared plus bx plus c. Circle that squared. When x is squared, that's going to form a parabola. That's in standard form. Again, these are all on your reference materials, which I've posted on Google Classroom as well. And we have another type of quadratic equation, and that's y equals a x minus h squared plus k, and that's your vertex form. And then your exponential equations, this is what we're going to start talking about a little bit more over the next couple of days. It's y equals a times b to the x. When x is in the exponent, that's when you have an exponential equation. Exponential sounds like the word exponent. Y equals a 1 minus r to the x. That's called exponential decay. We'll talk more about that. Y equals a 1 plus r to the x. That's growth. Subtraction, decay, addition, add. This equation's on your reference sheet. These 2 are not. These would have been ones that you would have had to memorize for your EOC. Now let's differentiate based off of the rate of change or slope. When we look at lines, the rate of change or the slope is constant for linear terms. It's either positive, negative, 0, or undefined. A quadratic equation, the rate of change or how the variables change over time is not constant. It's not consistent. We have a positive slope right here, but then we have a negative slope right here. We have a negative slope right here and a positive slope right here. The rate of change of the slope is not constant. For an exponential equation, the rate of change either increases or decreases, but because the line is curved, it's not at a constant rate. Like a positive or negative sloping line, this curve is going to increase or decrease at a different rate. So it increases or decreases at a changing rate. And the final way I want you to differentiate between these types of equations is from word problems. You'll see in word problems with linear equations, you'll hear per, each, and every. We're not going to worry about quadratic equation word problems. Exponential word problems, you'll hear things like doubles, triples, quadruples. You'll hear percent, halves, and examples like that. This table you guys are going to use now to do the Gimkit. I found a Gimkit on linear, quadratic, and exponential functions that you will use to complete the money challenge there. And that will help you with differentiating between these three examples. As always, guys, please feel free to reach out to me if you have any questions or concerns. I love you guys so much and miss you guys so much. We are also going to be doing a virtual tutoring on Friday from 10 o'clock to 11 o'clock. I emailed you guys in your Uplift emails, which you all should know how to access from Miss Whitehurst's technology class. But I've also posted the link in both this morning and this afternoon's lessons so that you can click on that if you'd like to get some help on the quadratic equation. Several of you have asked me about that, and I'd love to give you guys some help on that. All right? I love you and I miss you.